Right. So given some sort of stock over time, that looks like this. Right. Some sort of stochastic process. Let's see as 15. Right, this is time and this is price. What we want to study is we want to basically study the convergence of this kind of graph. Now, note the following. I'm going to talk about what it means for a graph to converge over time. So, for a graph to converge over time, as I go say like this, I'm going to note all the points at which it comes, right? This is the y-axis, so this is the y value over time. And this is the x-axis, which is time. Right? So basically, as I go along further in time, you should start to notice that as this thing flattens out, if I trace back its if I trace back its line all the way up to the x-axis, to the y-axis, then this point is never crossed, because as it goes out to infinity, these both points get parallel. So this is the notion behind convergence of any smooth graph. However, first thing to note is that this thing is not only smooth, it is discrete, not at all smooth at all. And secondly, it does not converge at all. I don't think anyone has seen a share price converge to anything that isn't zero, right? So what we are going to do is we're going to study the convergence of its subsequences. So given some sort of sequence, I'm going to convert this stock, this share price thing, into a share sequence, which is only going to be its price over time. So say $10, $11, $1, $11.5, $11.6. Let me give some more. Let me actually try to explain the point I'm making, right? So this is my sequence, and then I have like $4 out of nowhere, I have $6 out of nowhere, I have $11.7 out of somewhat nowhere, I have $10 again, and so on. Okay. So what I want you to notice is that I have a sequence here, yes. However, if I select just a few points over here, I get a subsequence. What is that subsequence? I'm going to take 11 over here, 11.05, 11.06, 11.07. What do they seem to actually converge to? They seem to be getting closer and closer to the value of 11.1. Yeah? In reality, or 11.10. So, in this case, I would say that my subsequence is sort of converging to a point. However, this is in a finite sequence, right? We're interested in infinite sequences. So convergence is only defined for infinite sequences. In some sense, this is also an infinite sequence if I start plotting these points, these points, these points, and these points. Similarly, if I start plotting this point over here, this point over here, this point over here, then I go back to this point over here, I have this point over here, this point over here. Let's do it more. This point over here, 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 and so on. Right? So if you'll notice, this area sort of has a lot more points projected on the x-axis than the other points. And in some sense, that is because if you consider the subsequence of all the points contained here, then the subsequence of all the points contained there actually converge. So I'll show this to you as I draw more and more. This goes down here, this also goes down over here, and so on. So the study of infinite sequences and the convergence is a subject of real analysis. So we will be using concepts from there to talk about convergence over here, and we want to not just study convergence. This over here, when some point, let's say I have a graph like this, and let's say over here it starts here, then it starts here, then it starts here, then it goes here, here. Oh, it's not drawing also. Turns out one node is anti, is against convergence sequences. But yeah, you see how it slowly approaches this limit, right? So this is the essence of convergence, and more specifically, this is the essence of strong convergence, right? And we have multiple notions like weak convergence, and our research project is going to study these, specifically even weaker than the traditional weak convergence. Weaker convergence. Okay. And that's all for sequence analysis. We will be looking at some other theories for reference. Namely, we're going to be looking at something called summability. Here for this project.